Kia ora. My name is Pat. In 1976, I graduated and I wanted to go to Antarctica. So I applied to British Antarctic Survey, and they were interested in Patrick Langhorne. Patricia Langhorne, wrong gender. So instead, I went to the Arctic. And I spent time with this man here. It was just as satellites were first going up and monitoring what sea ice was doing on the surface of the ocean. And so Jamie wanted to use radar to measure sea ice thickness, to make his contribution to remote sensing. First of all, though, we've got to know what sea ice is. Sea ice, as we heard from Natalie, is frozen ocean. It's usually less than 2 meters thick, and it's salty. We can see it up there on the right-hand side of the slide. It's white, and because it's white, it rejects the heat that would otherwise go in the ocean. It also rejects cold, salty water, as Natalie told us, and drives heat around the globe. And then for us, it's sometimes our nearest neighbor at some times of year. And so it controls the storm and weather systems around New Zealand. In this slide, we can see that when there is most ice in the Arctic, there is least ice in Antarctica, and then vice versa. So in September, there's more ice in Antarctica and less ice in the Arctic. Most importantly, though, sea ice is home to these Adelie penguins and to the seal we just saw in Natalie's slide. Anyway, getting back to me, in the 1980s in the UK, sea ice research was seen to be a bit flamboyant, a bit frivolous. So I decided I better do something useful. So I went off to be a jet engineer for a few years. But as soon as the invitation came to go down south with the New Zealand Antarctic program, I was there. The experiment was to work with this truck and this man, driving faster and faster along a sea ice road, measuring the waves that the truck generated. Notice it says salvage truck. It was chucked out by the Americans onto the melting sea ice, and the Kiwis rushed out and did it up. Anyway, when Bill went faster than 60 kilometers an hour, it was scary. So he convinced a C-130 aircraft to fly very low over the ice road, and I got to talk to the pilot on the radio. The thrill of that brought us to New Zealand. So let's look at some of the scary facts that we know from having satellites up. This is sea ice in the Arctic in 1979, sea ice in the Arctic 2020. You don't need a PhD to see that bad things are happening. And it gets even worse if you look at the age of the ice. The blue is young ice and the red is old ice. Young ice is thin, old ice is thick. So Arctic sea ice has gotten younger and thinner over the last 40 years, unlike me. What's happening in the Antarctic? Well, the jury's kind of out. 79, 2020, there is not much change. It varies from year to year and place to place. But what about sea ice thickness? Well, the shameful thing is that even after 40 years, the frickin' scientists still don't know much about how thick Antarctic sea ice is. And that's because it's hard to work out. Sea ice in the Antarctic is thin, it's snow-covered, it's on the most famously rough and disturbed ocean in the world. We've just heard from Natalie, too, that the ice on the land interacts with the ice on the sea. It blows the ice away from the shores in areas called polynyas. Never take a holiday in a polynya, by the way. Seriously horrid place. And most of the growing goes on in the middle of winter. So the highlight of my career has been to take part in 2 winter over sea ice expeditions. And this is a camp on the sea ice in the middle, about lunchtime, in the middle of July. There's someone walking with a head torch on. All right, back to sea ice thickness. 1977, this is what we were doing. Jamie had his radar down on the ground, didn't work. Put it at waist height, didn't work. High up, didn't work. All right, helicopter, didn't work. The problem was sea ice is salty. We have made progress, though, over the last 40 years. We've got Rosie. Rosie is an electromagnetic induction device, and she flies at very low altitude, towed by this beautiful DC-3, built in 1943. Then we make measurements on the sea ice, and that's not necessarily easy. Here's Gemma having fun, and Gemma having fun. And we compare the measurements that are made on the ice with the measurements that are made by Rosie. And then the measurements that are made by Rosie are compared with measurements that are made by satellite. Nowadays, the satellite measure how far above the ocean the ice is floating. That's that much. And they measure that on the rough and stormy ocean. So Rosie has now surveyed 4,000 kilometers for us. So sea ice is super cool. In the 40 years that I've had a love affair with sea ice, we have made some progress. I hope it sticks around because it's doing a fabulous job at keeping our world the way we like it. Thank you.